First is that Bitcoin's boring. So this is by design and is often pitched as a problem. This is sort of the original problem that Ethereum was built to solve. You can't really do much with Bitcoin. It's just that ledger. And it's really just a money and maybe a settlement layer, but you can't do that much with it, and that's by design. The more complex the execution environment gets, the more of an attack surface there is. The more complex the code base gets, more of an attack surface, but also just the more risk of even non-malicious, just bugs and mistakes. So Bitcoin is intentionally boring and intentionally simple. And a big key part of its ethos and why it exists is to keep it that way. Next argument is that Bitcoin is wasteful. This one has always seemed a little bit silly to me because if you look at the energy usage of Bitcoin, there are plenty of things in the world that use more energy that we generally don't bat an eye at. So why does Bitcoin get attacked? And I think the reason is because there's this value disconnect. We understand that energy is a resource that should be used in order to improve human quality of life. And so if we have something like the current global financial economy or household appliances in America, both of which use more energy than Bitcoin, we don't constantly see people going around talking about how wasteful it is because people understand that those things have value. So if you look at what Bitcoin is designed to be and what it can be, there's a difference here in how you think about what wasteful means. If Bitcoin is something that the entire decentralized global economy is built on top of, then it would take a very, very large amount of energy for that to be considered wasteful. And so this is just a different way of looking at it. And then again, this is something that we'll get into in a little bit later. But again, this is where stacks can help to sort of unlock some of that functionality to increase that value proposition. Next is that Bitcoin is slow. This is probably one of the biggest sort of drawbacks that you hear people talk about with Bitcoin and why other blockchains exist is that it's slow. And again, this is sort of missing the point of a blockchain. People want performance, they want speed. I get that. We're living in an era where user experience is extremely important, especially when we're coming from a traditional Web 2 architecture, which highly focuses on speed. But the error I think that people make here is thinking that the base chain being slow is a bad thing, when it's actually not, because without it being slow and without it having to propagate to the entire network, we again lose some of those critical properties of decentralization and security. Related to that, Bitcoin doesn't scale. The transaction throughput is pretty much the same. It's very slow, but again, not generally a problem for the base layer. We have other solutions that are built on top of that base layer that are meant to solve things like this, things like Lightning, which actually has a faster throughput than the Visa network. So the interesting thing here is that all of these arguments, all of these problems, they have hints of truth in them. And so they've inspired these other chains to come in and solve these problems. Chains like Ethereum, which was sort of the original Web3 chain that really said, okay, Bitcoin is great, blockchain technology is great, but there's a lot more potential here. There's a lot more that we can do with this. Let's take what Bitcoin did for money and let's do the same thing for software, where we have this decentralized global supercomputer that has compute power and an execution environment so that we can take the same decentralization benefits and censorship resistance and true ownership that we get for money with Bitcoin, and we can do the same thing for software. So it originally was made to solve the boring problem, but now it also solves the wasteful problem through proof of stake, which we'll get into in a little bit here. Solana, another really popular one that came to solve the slow problem. But again, when you look at how Solana operates, it's much more decentralized than Bitcoin. And so by solving the slow problem, because the data has to propagate to fewer nodes, because the nodes have higher requirements, you may increase speed, but you're decreasing the decentralization and security of the network. And then we have these newer sort of modular build your own blockchain systems like Cosmos and Celestia. These are interesting because they're made to solve the does not scale problem. But what I think is the drawback with these is that if we're talking about something that is building an entire global economy, each individual organization spinning up their own blockchain doesn't really make sense for that, because then we're not in a much different place than we are now. It's not to say that this doesn't have its use cases. It does. Like, for example, Walmart right now is experimenting with using a private blockchain in order to run their supply chain systems. That's a great use case for something like Cosmos or Celestia or a proof of stake system, where the scale of the problem being solved is much, much smaller and much more particular to one organization or even a small group of organizations. But when we're talking about this core problem that Bitcoin was meant to solve, which is this global peer-to-peer decentralized money, and then what Stacks is designed to solve, which is to build an economy on top of that, these design choices don't really make sense to do that. So they solve different problems, but I don't think that they're good to be like sort of the primary global decentralized software system. And then we have other ones that are coming up now, Near, Avalanche, and others that are all designed to solve different problems that came up with Bitcoin, designed to solve different problems with Ethereum. They all have these different design choices that they make, and they all claim to solve these different problems. But the key thing to keep in mind is that they all have to sacrifice some critical element of blockchains in order to do this. They all have to sacrifice one of those elements that we talked about before at the beginning in order to accomplish these things. So the thing we need to ask is, are the problems presented by these other chains, are they real? Are these issues that Bitcoin has, are they real problems? Or are they strengths and properties that we need to sort of find a different way to address? So these chains correctly diagnose problems, but they don't necessarily provide an adequate solution. And I have an asterisk right there on correctly, because while they're identifying things that are happening, I think that they are incorrectly diagnosing them as problems, when in actuality they are features and they should not be modified, and we should layer other systems on top of that foundation, keeping those properties instead of trying to change the foundational system itself. Because then what happens is that they attempt to solve these false problems, but all they're really doing is introducing new ones in the process. So it's important here to keep our context in mind, going back to the beginning of what we talked about. The goal here is to create a global economy that eliminates forced centralized ownership and enables true ownership. That's the goal here. So if we look at the two most popular consensus mechanisms, which are currently proof of work and proof of stake, Ethereum just recently successfully completed the merge and moved over to proof of stake. And so I kind of want to spend a little bit of time comparing and contrasting those, because currently proof of stake is by far the most popular consensus mechanism for building Web3 apps on top of. So, and proof of stake is pitched as this fix to proof of work. So it's a way to achieve the same security without the drawbacks. That's the sort of the elevator pitch that we hear all the time. If there was a way to achieve the same security of proof of work, but with 99.9% less energy usage, why would we not do it? When it's pitched like that, that's a great argument. The problem is, I'm very skeptical of the claim that it provides the same security. So proof of stake is built on certain technical foundations that have really important social and economic implications. The first of these is that it's a negative incentive system. So something like proof of work, the miners are working in order to gain a reward. They're working to gain a reward, and the worst that can happen is nothing. There's no negative incentive there. If they fail, if they try an experiment in their mining rigs and it doesn't work, they just don't get any Bitcoin, but they're not losing anything. If you look at something like proof of stake that primarily operates off of a slashing mechanism where validator nodes are punished if they do something incorrectly, that's a much different environment, and it's a fear-based environment rather than an exploration and inventiveness-based environment. This doesn't seem like that big of a deal until you start to draw this stuff out long-term, which is what I think is important to do. I want to be clear when I talk about this. I don't think proof of stake is useless. I think it has its use cases like we talked about a few minutes ago. I also don't necessarily think that we're going to see most, if any, of these negative impacts in the near future at all. But what I'm looking at here is I'm looking to expand out the timeline and look at if the world becomes blockchain enabled 100 years from now, what system do we want that economy to be built on? When we have something like a negative incentive system where the people in charge of running the network have their own personal assets staked into making sure that the correct outcome happens, that really slowly starts to create this sort of toxic fear-based environment. And I think we can see this in the systems that are alive and well today. When you have a system like this in which the majority of people that have assets within the system have the potential to lose those assets if they don't go along with what's seen as correct in the system, I think we slowly start to see this scope creep where the people that have the most social influence on the system begin to just slowly get their way over time, usually in the name of safety or security for the users. And so this is the primary concern that I have with proof of stake and with Ethereum, is that over time, it's slowly going to morph into basically the exact same system that we have now, where the people that are at the top and the people that have the most invested into the current system have the most ability to also continue to gain from that system. Now, I'm not talking about governance, because I understand that your stake in a proof of stake system does not impact your governance, but what it does impact is your ability to decide what transactions should and should not get published. Again, I don't foresee this becoming an issue in the near future. My concern is the slow progression that this sort of incentive environment is going to create over the course of the next few decades. The second issue is that it's relatively permissioned. It's a minimum of 32 ETH that you have to stake in order to become a validator. There are technical reasons for this, but The point is that that's a very large amount of money in order to become a validator. Now, usually the argument here is, okay, but you can join staking pools. And while that's true, that then does just contribute again to this decentralization or centralization aspect where, yes, you may have a pool of multiple people that are all staking their assets, but that singular organization is still what is in charge of validating. If we look at something like Coinbase, which has a very large staking pool right now, they are currently staking, I think, something like 25% of all of the staked ETH right now. And that's a centralized traditional organization that's subject to regulation just like anything else is. And so it's just another one of those patterns that we see that may not be an issue for a long time, but over time, if we continue that trend of having such a high barrier to entry in order to become a part of the network, I think we're going to start to see problems there. The other part of this is that, let's say that you're a Bitcoin miner. You can buy a Bitcoin mining rig for a few $1,000s, or you can join a mining pool if you're not quite to the economy of scale as being able to be a profitable solo miner. So you can join a mining pool. The difference here is that you can point your node at any other mining pool you want instantly. The way that the staking system is set up right now, one, you can't just become a validator whenever you want, even if you do have the 32 ETH. You have to go through this process of being accepted into the validator network. And then on top of that, right now, the code to pull out your stake hasn't even been written yet. And so there's no guarantee that you're ever going to get that ETH back. Now, I'm not gonna be part of the camp that says that Ethereum can't ship. I think they proved that technologically they're capable of a lot with this merge. That was a huge achievement. But the fact is that so much of what proof of stake systems currently rely on is future solutions, not solutions that exist right now. And then this is related to the point that we had before, but I think there's a pretty clear path to oligarchy when you look at a proof of stake system and how it works, because the incentive structure actually makes it undesirable to have new validators, because anytime a new validator comes in, the current validators get their assets diluted. So they're not making as much money when a new validator comes in, because the ETH block rewards are getting distributed out to more validators. And so if we have these singular or small organizations that have such a majority stake in the network, what I don't think is going to happen is I don't think it's going to be a just blunt, nope, nobody's allowed to become a validator. But again, I think this is where we'll start to see those social and economic patterns of the people that are in control slowly implementing tiny little stepwise changes in rules to the point where it's almost impossible for anybody else to come in and be a part of that network. And then at that point, we have the exact same system that we have now. We have a system where who controls what transactions do and do not get recorded to this ledger is a very small group of people. And that's exactly what we're trying to avoid with this. And the last thing is that it's subjective. So if we look at something like proof of work, it's an objective fact, which is the correct chain, and it's the one that has the most work done. But so much of a proof of stake system relies on social consensus. What the real chain is basically just what everybody decides that it is. So there's no objective reality here to anchor the chain to. It's a subjective social opinion and social consensus, which again, in some systems may have some benefits. But when we're talking about building a global economy, that's a very dangerous precedent to set. And then this one arguably may be temporary, but if we look at singular organizations like Coinbase and Lido that collectively currently stake almost 50% of all of the staked ETH on the network, we're now sort of flipping this pyramid that a blockchain should be built on, where the most stable layer should be at the bottom and support all of the smaller layers on top of it. When we have this proof of stake system where so much of the stake is controlled by these singular organizations, that just creates another bottleneck and security risk, because so much of the liveness of the chain actually being able to run is dependent on such a small amount of people. So is proof of stake worthless? No, I don't. I don't think proof of stake is worthless. We talked a few minutes ago about how companies like Walmart are experimenting with private blockchains. I do think that there are other use cases for blockchains outside of a decentralized global economy. I just don't think that proof of stake is the correct protocol and the correct consensus mechanism to apply to something like that. Now, Stacks and Bitcoin, Stacks and Ethereum actually have very similar goals to solve a lot of these issues with Bitcoin and sort of just move it to the next level, but they do it in very, very different ways. So to wrap up that part, proof of stake has value for certain use cases. Do not think it's appropriate for a global decentralized economy. But that's not to say that there are not legitimate problems with Bitcoin that some of these protocols seek to address. I just think that they address them in the wrong way. And I think that Stacks addresses them equally well, if not better, without a lot of the drawbacks of a proof of stake system that we just talked about. So the first thing is it's not sustainable. I'm not talking from an energy perspective here. That's a different argument. What I more am talking about here is at some point, the block rewards for Bitcoin are going to go away, and the network is going to have to sustain itself on transaction fees alone. At the current trajectory, that doesn't seem super likely because the incentives are not going to be enough to have it be as decentralized as it is now. The next thing, that there's no value accrual. So there's no built-in way in order to generate a yield on your Bitcoin. You can hope that the value of Bitcoin goes up, but there's no way to actually generate a yield on that Bitcoin without just handing it over to a centralized custodian. There's no meaningful apps on Bitcoin. Talked about this before, but Bitcoin is a very, very limited in its scope of what it's actually able to do. And so because of that, it's very difficult to build actual meaningful apps on top of it, which can then bring in more capital and sort of unlock that economy on it. And then it does use a lot of energy. This is often pitched as a negative. I actually don't see it that way. I actually think this is one of Bitcoin's main strengths, is that it actually requires some external expenditure of resources in order to create new Bitcoin, in order to protect the network. But the more functionality that we can get out of Bitcoin, the further that energy usage will go. And if we can do that in a way that's not going to compromise Bitcoin security, then that's the way we need to do it, which brings me to the Stacks way. So what Stacks is really meant to do is solve a lot of Bitcoin's problems, but without Ethereum's weaknesses. So this right here is a very simple chart, but I really like the way that it's laid out because it very simply sort of highlights the difference between the Ethereum approach and the Stacks approach. So if we look here on the left, we've got Bitcoin here as the foundational base layer, and we've got Stacks there on top of it. We just heard from Sarala about subnets. That's another layer that would be on top of that, on top of Stacks right there. And what this is doing is that this foundational layer that's bigger at the bottom, we want that to be as strong and robust as possible. We don't necessarily care as much in this particular area about speed or scalability. We want this particular foundational layer to be strong and solid and honestly be as simple and boring as possible because it needs to be the most stable. As soon as you introduce complexity, you introduce more risks, which brings us over to the right side. This is the difference in how Stacks handles the layering approach to adding functionality to Bitcoin versus how Ethereum handles its layering approach. A true layer 2, like what you see in Ethereum, is going to only inherit the functionality of the base layer, but maybe make it more scalable. So if we look at something like Lightning for Bitcoin, that's taking the same functionality of Bitcoin, but it's making it much, much faster and much more usable. But you still can't do anything else other than basically send and receive money using it. Not a bad thing. That's another perfect use case for this layering approach. We have Bitcoin as the foundational settlement money layer. We have Stacks as the programming layer, which can help us unlock an actual decentralized economy and real useful decentralized finance using Bitcoin as the money. And then we also have Lightning, which can be the payments layer on top of that. With Ethereum, with everything being at the base layer like that, you get more and more complex, which introduces more and more security risks down the road. The Ethereum code is massively complex. And so I think that a better approach is this more separated layers approach. So one of the things that Stacks does is it just expands this utility of the energy expenditure. So we talked about this a little bit before. One of the main flaws of Bitcoin is that it uses a lot of energy, but I think this perspective will shift the more useful Bitcoin gets and the more people perceive it as being useful, then people understand what the energy expenditure is for. Stacks can really help us do that because it unlocks a lot of new use cases for Bitcoin. When I talk about new use cases, what I'm really thinking about here is all the things that you can do in the traditional financial system right now. Get a small business loan, get a mortgage, get a car loan. All of those things should be able to happen with Bitcoin, but you should be able to do them without having to trust somebody else with your Bitcoin, which is currently the only way to do it. Or you can move it over to arguably a less secure chain like Ethereum. Stack solves that problem. It also expands functionality without increasing complexity at the foundation. This is what we just talked about a little bit. I do have the asterisk here that I want to go over right now, and that's because I don't think that this functionality does not exist in the way that it needs to right now. It's a work in progress. So I want to be careful here with saying what Stacks can and can't do at the moment. The real ideal vision for Stacks, where it unlocks this decentralized economy with Bitcoin, that's a work in progress and it's on the way. But this is something that I see really starting to expand and get better in the future, but it is limited right now. And then so it unlocks this potential for decentralized value accrual. So if you look at staking Ethereum, you get a yield on that Ethereum that you're staking, so you're generating value accrual. So a lot of people want to be able to do the same thing with Bitcoin. Currently, the only way to do that is to trust it with a custodian or to bridge it over in the form of wrapped BTC onto the Ethereum network and have DeFi protocols there. But then again, you're having to then trust the proof of stake system with your Bitcoin. Ideally, we would like that to all happen within the Bitcoin ecosystem. And then finally, we have safer smart contracts with Clarity. Clarity is the smart contract language that Stacks utilizes, and it's intentionally built with safety and security in mind. So we've taken a lot of the lessons that were learned from Solidity and from Ethereum, and we've made a programming language that makes it much more difficult to write some of those bugs and much easier to write safer smart contract code, which again, if we're talking about something that's handling people's assets, very important. And then the big vision here is that Stacks allows Web3 built on Bitcoin. So if we go back again to the very beginning, what the purpose of blockchains are, what the purpose of Web3 is, it's to eliminate this forced centralized control and to enable true ownership. I really do think that Bitcoin is the best foundation to build that on top of, but it's not going to get there on its own, which is why we need something like Stacks in order to work together with Bitcoin. Stacks needs Bitcoin. Stacks literally cannot exist without Bitcoin. It's not trying to compete with Bitcoin. And I would argue that long-term Bitcoin also needs Stacks in order to unlock some of this functionality and activate that economy. Thank you so much for being here today. My name's Kenny, developer advocate, Stacks Foundation. There's my Twitter. And if you go to start.stacks.org, that's a great place to sort of get introduced to the process of Stacks development if you're interested in building on it. Thank you so much.